over the test, obviously, but that's okay. So there's a question. How can you choose the correct amount of two items when both items are desirable? Give me an example of a time when you had to make a choice and you wanted both of those things. Let's talk. Give me an example. Somebody has an example. Jasleen. Yes, absolutely right. Good answer. Okay, I'm gonna build on your example because that's actually perfect. Okay, all of you know I have dietary restrictions. Yes, you know this. So most quick and easy fast food is out of my diet. I can't eat McDonald's. I can't eat Wendy's. Actually, at Wendy's I can get chili. Oh. But seriously, folks, most of the stuff I can't eat. Right, so I'm restricted pretty heavily in what I can eat. All right? Now, I budget for myself $20 a day, of which I can do anything I want with. I have other stuff, right? I got a budget for gas, I got a budget for groceries, but I have $20 that I reserve just for me. I don't have to have a reason to spend it. I just have it. Okay? All right. I'm going to go out for lunch all day, every day this week, right? So, obviously, I have a maximum amount I can spend, yes? What is it? $100. $20 a day times $500, yeah? Okay, everybody cool? Now, what are some things I can eat? Well, in the other class, I'm lucky. Aiden's in that class. His family actually owns the Phoenix Diner. And he's seen me there a few times. He knows I like the pho. I can't get enough of the pho. I love the pho. I love the pho out of the pho. Okay? You might call it pho. But it's not pho. It's pronounced pho. Right? So anyway. It's too bad it's pronounced pho. Because you can make lots of puns on pho. Like if it's the best place ever, they're the king of pho. Yes, I know. Yeah, but it's what the pho, right? But if you say it wrong and say pho, you can also make one. It's like, what's pho dinner? I'm pho hungry. Anyway, and the other thing that I can eat a lot of is Indian food, right? And the other thing I can eat a lot of is tacos. Yeah? Okay. Yeah, if they're corn tortillas. So, right? Everybody cool? Not burritos, just tacos. Everybody good? Okay. So, in grade 11, we stick with only two variables, okay? So I'm going to use Indian food and pho. Everybody agree? Those are my choices. I, for my lunches this week, can eat some combination of pho and Indian food, right? Everybody understand? So I could have pho 5 days a week. I could have Indian food 5 days a week. But I don't want to do that because I go to school and I work in this nice big city that has lots of both. So I like to mix it up a little. Right? Those two things have maximums of $20 I can spend per day, yeah? Everybody cool? So how do I decide? Average pho meal, by the time I've gotten tea and a Coke and a large pho and a salad roll, $22 with tip. Everybody cool? Can I eat pho 5 days a week? No, I cannot. Why? Right? So at some point, I got to get me some Indian food, yeah? Indian food, I go to Gian's Buffet over on what's that street? South Fraser Way, because I think they're $13.95. I think. Right? I don't care what it is. It doesn't matter. I know the restaurant I mean. Another restaurant I like to go to is that little one right over there. I don't know what it's called. Zaikal? I don't know. It's just the Indian place that you got to go downstairs to. I like that place because they have gluten-free pakoras. I eat a lot of those. All of them. All the flavors. But the chicken ones are a little weak because chicken is just chicken, right? But the fish, and ironically, I love the veggie ones the best. Yeah. Anyways, that's neither here nor there. So obviously, I cannot eat pho 5 days a week, right? Could I eat pho 4 days a week if the Indian food, by the time I've paid for my tea or whatever I'm drinking there, say I'm getting a Pepsi, because they never seem to have Coke at Indian restaurants. It's always Pepsi. Is this true? Every time I order a Coke at every Indian restaurant I go to, is Pepsi okay? And then I get to do that Steve Carell thing. No, but I guess I'm stuck with it. But Steve Carell does it the other way around. Is Pepsi okay? Of course it's okay. No, it isn't. Pepsi tastes like ass, but that's beside the point. Where was I? Oh, right. $16 for Indian food by the time it's all said and done. Tax, tip, everything. Can I eat pho 4 days a week and Indian food once? Why not? Because I'm over budget, right? So, what does that say? That says to me and to you that my pho plus my Indian food has to be what? Less than $100, yes? Or equal to. There we go. Now, how many of you have ever had to budget for anything? All of you. So how many of you use inequalities all the time? All of you. What would I have to write here if I have two variables, yes? What? Oh, good gravy. And how much were those pho meals? And all of a sudden, I'm graphing lines, right? Everybody cool? So, whereas in the olden days, way back in grade 10 when you were young pukes, you just drew a line. And the answer was all the way down that line, right? But now, how many answers are there? One or more than one? More than one. Everybody cool? All right, let's apply this. See what we can do. Read that paragraph and talk to me. Hint, hint. It's the exact same scenario I just gave you, except it's music. Do I have variables? What are they? We're going to make them X and Y. That's cool. But what do X and Y represent, McKenna? Does the card vary? Songs and albums. We're getting to that. Okay. So Priya, the card doesn't change, does it? It's $15, right? So there's albums and there's songs, yes? Now, sadly for the music industry, iTunes, Spotify, Apple Music, YouTube, all those things have ruined albums because now you can pick and choose. So you never actually hear everything a band has to offer. You hear the songs you like by that band over and over and over and over again, which is bad for the music industry, but what are you going to do? Two variables, yes? One of them is what? X, because we got to graph it as X, right? Because on a graph, we're restricted to X and Y. Okay, so albums are X, agreed? Songs then are what? Excellently done. Now, what do we know that we are allowed to spend on this website? $15. Is that what we are going to spend, or is it a boundary for what we can spend? It is a boundary, is it not? I don't need to spend $15, but I could if I wanted to, right? So, what can I do mathematically to express this? Well, in words, the albums I buy plus the songs must be what? Less than or equal to 15. $15. So I have to think here. Because I cannot buy 15 albums, can I? No. What is one album going to cost me? $5. So it must be 5x plus how many y? 1y, because one song is $1. That has to be less than $15 or equal to, correct? Now, if I told you you were not allowed to spend anything but $15, if you activate this card and don't spend $15, we're taking back the money, which is kind of what gift cards do. That's how they make money. That's why they're a scam. That's why you should never buy them. But that's beside the point. How would you take your current grade 10 knowledge and figure out what combination of albums and songs we could buy if I was restricted to spending only $15? Talk amongst yourselves. I'll give you a hint. What part of that has to change if I am restricting you to spending $15 and only $15? All right. My good friends Priya and McKenna have informed me that if I restrict you to spending $15, this sign can no longer be that, can it? What is it? 5x plus y equals $15, yes? Okay, but there's some options here, aren't there? Because I could buy how many albums? 3, which would mean I could buy how many songs? None. I could buy 15 songs, couldn't I? Which means I would buy how many albums? 0. So, I can take this and do this lovely move that you all remember. Right? Albums are X. Albums. Songs are Y. Negative 5x plus 15. That plus 15 is what? The y-intercept, yes? So where do I go? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If I buy 15 songs, how many albums can I buy? None. What's my slope? So what's my slope? Negative 5. Now I'm going to stretch this out for illustrative purposes. Everybody okay with that? I'm going to go 1, 2, 3, 4, 5 and make that 1. Everybody okay? 1, 2, 3, 4, 5, make that 2. And 1, 2, 3, 4, 5, and make that 3. Agreed? If I buy 3 albums, how many songs can I buy? 0. This is going to graph a straight line, isn't it? Isn't it? Okay. How do I know it's going to graph a straight line while I make my pen do what I want it to do? What's missing? An exponent. Right? It's automatically going to be a straight line. Right? Why does the straight line end there? I can't buy negative songs. And I can't buy negative albums, and I can't buy negative songs, right? Now let me ask you this. Could I buy 1 album? Okay. If I buy 1 album and 1 song, is that okay? It is, isn't it? Because 1 album is $5 and One song is $1, so I've spent how many dollars? So am I okay? Excellent. Could I buy 2 songs? Could I buy 3 songs? Could I buy 4 songs? 5, 6, 7, 8, 9, 10, 11? No. Could I buy 2 albums and 1 song? 2 songs? 3 songs? 4 songs? 5 songs? 6 songs? No. Can I buy half an album? No, I can't. Can I buy 15 songs? So, let me ask you this. Knowing what we know about restrictions, and that I cannot buy half a song or half an album, now that you've seen this many dots are under here, what do you think about all of the dots under there? They are all going to be okay. What about all of the dots out here? They are not okay. Does everybody understand? Okay? Last year, you learned how to deal with just what you were allowed to do. No wiggle room. Now, much like real life, you can learn to optimize or make the best decisions to deal with your money. Or whatever it is you are budgeting. Everybody cool? All right, let's do some math terms with this now. A linear inequality in 2 variables is in one of the following 4 forms. It will always look like what I am about to show you. Now, when we write things in general form, you people get confused because you see ax plus by. And then I give you an actual question that is 3x minus 7y is less than negative 12. And you say, what? Please recognize that this is 3x plus negative 7y is less than or equal, just less than negative 1 times 12. Okay? You're aware of that, yes? Just because it says plus there doesn't mean it's always addition. Well, it does. It means you're adding a negative. Everybody cool? That's just a little warning I want to get out there for you. Everyone's okay with that? All right. Now, let's start talking. You've already answered this one. What 2 variables do we always like to use? We always like to use x and y, right? But those are variables that represent what? Any 2 options. All right? Any 2 options. Albums and songs. Indian or pho. Okay? Am I going to vacation in Ecuador or Spain? Any 2 songs. Okay? Well, my Brazilian friends haven't invited me to Brazil yet, so I'm not going there. Hint, hint. Everybody understand? Okay. Now, you all also know this answer to this next question. What mathematical construction, something we use in math, something you can see, lends itself to discussing 2 variables at one time? This is not a trick question. A graph. What do we actually call the graph, though? The thing that we graph on. It's got 2 names. One is the old school, old, fat, white European guy's name. Cartesian plane, and the other one is the new, more politically correct version of what we say. Coordinate grid. Okay? Now, why is the coordinate grid so great for this? Because it has x's that can increase or decrease, and y's that can increase or decrease. Yes? Now, often in real life, we don't use 3 of these quadrants, do we? In real life, we often only use this one. But they're all there for us, yes? Okay. The ordered pair. I've left a blank here. What are we filling in there? What is every single ordered pair in the universe? X, Y. Now, maybe it means albums and songs. Maybe it means Indian and pho. Maybe it means Ecuador and Spain. Maybe it means who cares? It's the 2 things you're counting. Everybody cool? That ordered pair in grade 9, in grade 10, that ordered pair had to live on the line. Yes? In grade 11, that ordered pair can live in an infinite amount of spots because there's an infinite amount of solutions to an inequality. Everybody with me? How do you know if it works? Well, the ordered pair is a solution to linear equality. If the inequality is true, which means it works, when x and y are subbed back in. So let me give you an example. On the previous page, albums were x, yes? Right? 5x plus y had to be less than or equal to 15, right? Right? Can I buy 2 albums and 3 songs? That was under the line, yeah? 2 albums was $10. 3 songs was $13. So the pair was 2, 3, yes? Is 10 plus 3 less than 15? So that is part of the solution. Could I buy 2 albums and 6 songs? No, because 5, 10 plus 6 is not less than 15. Everybody cool? How many times have we seen this? We take the ordered pair and we sub it back into our equation. We've been doing this for how long? Every year of math since you did length times width equals area, right? It's always this skill. Always. Everybody's good? All right. Now, the set of points. Because remember, there's more than one answer now, yes? The set of points that satisfy linear equality can be called 2 things. One, if it's in algebra, we call it the solution set. If it's on a graph, we call it the solution region. Everybody cool? And we're going to talk more about that in a minute. I'm going to highlight that in yellow. No, I'm going to highlight that in green because we're going to talk about that more in a minute. Now remember, this equality is important, isn't it? Because that equality gave us this line, right? And why did we know that point didn't work? It was above the line, right? And we needed to be less than the line. So that equality, and we know that an equality will graph as a line, right? What do you call a line between 2 things? Give me some English words for it. Pardon me? Satcho, I hate it when you do that. Boundary is the exact right answer. I just didn't hear you. Okay? It is called the boundary. Why? Because it does this. Here is my Cartesian plane, yes? There's a line. Oh, that should have been another color. There's a line on it, yes? What does that Cartesian plane, what has happened to it once you draw that line? It's split into two regions, yes? One of which is yellow, and one of which is blue. The solutions exist in the entire region. All right? Sometimes the solutions are greater than. Where do you think they live? In the blue or the yellow? Blue. For one solution region, ax plus by greater than c. So what must be the other one? Less than c. Is everybody cool? There are two solution regions because all your answers have to live in one of those two regions. The trick is we need to decide which of those regions. Everybody good? All right. How is this different from before? Well, from before, where did all the answers live when you saw something that looked like that? Where were all the answers? On the line. Previously, our answers were restricted to the line. But now we have an infinite amount of answers. Everybody good? Now, obviously, you know how I do this. I show you the general form of this, and then we use those skills to apply to real-life situations, yes? So let's start with a general form of this. What do you see right here? What is that? It's an inequality, yes? Now, when I graph an inequality, I am going to get what Satjo wisely referred to as a boundary line, yes? Because I know an inequality is going to split my Cartesian plane into two regions, yes? So I should find that boundary line first. How do I find that boundary line? What must I do to that to what do I do to that equation? What do? I change it to an equation, an equality, yes? So step one, I got to find the boundary. Find the boundary by graphing the line. And we remember a line is an equality or an equation. That shouldn't have crossed out. So what am I working with now? Equals 6. How are you going to graph that? How are you going to graph that? Same way we've been graphing it since the beginning of the 10th grade, and 80% of you were in my grade 10 class. What is the easiest way to graph a line? Pardon me? What intercept? The y-intercept. Yeah, but what do we call that form? Slope intercept, which means what has to be isolated? Y. Everybody isolate y. Go. What do you get? Y equals what, Zach? I'm sorry? Negative 2/3 x plus 2. Graph that line. Where do I go? Up 2 on the y-axis, and then what? Rise over run, right? So I can go up 2 and left 3, down 2 and right 3. And what do I know about that? What do I know about this pattern? It's going to make a line that will go for where? Where will that line go? Up forever, left forever, down forever, and right forever. Because we now know that that line is going to divide the Cartesian plane or the coordinate grid in 2. Yes? Everyone agree? So now all of my solutions must live in the yellow or the blue. Yes? Now, most teachers will simply say, this is less than. So you color in below the line. Everybody cool? It's real easy when you have it this way. I will suggest to you another way to do this in a moment. But have we set up our Cartesian plane? Is this set up right? Do we have our 2 solution regions? Do we have our boundary? Yeah? Okay, now let's check. Is that part of the solution? Well, where is negative 2, 4? I'll put that with a green dot because I highlighted it in green. Where is negative 2, 4? 1, 2, up 1, 2, 3, 4. It's right there. Everyone agree? Is it part of the solution? How do we check? Plug it back in. So I would have 2 times negative 2 plus 3 times what? 4. And then I would check if that was less than or equal to 6. What's 2 times negative 2? Negative 4. What's 3 times 4? Negative 4 plus 12 is? Is 8 less than or equal to 6? No. So is this a solution? No. So what about that point? Would that point be a solution? No. What about that point? What about that point? No, because just like when we drew this line with one variable, everything that it's not covered, everything doesn't work. So this is all wrong. So where do I shade? Where the answer is right. Is everybody with me? The reason we shade is because all of these numbers work. Every single one of them. Down to where? Negative infinity and negative infinity. Everybody cool? Now, I am going to offer you an easier way, I believe, to check where to shade. What is the easiest number to work with? 0. What point is that? 0, 0. Is 0 plus 0 less than 6? So if that is one of the solutions, that means everything on that side is one of the solutions. That is what we call a test point. Now, in this question, I gave you a test point, and we used that. Okay? Everybody cool? Yeah? All right, now there's one other thing that's weird here. Actually, there isn't. I'm not going to cover that yet. I want you to try to do the same thing down here on your own. Go. And that will probably take us to the end of the day. This is all you're going to do today. See if you can make this, do this one right. And then I'm giving you the rest of the period off, and I'm giving you the night off. I am going to add, I wrote 1. Step 2, shade after using a test point. Yes. So as soon as I see the greater than or less than, what do I know? As soon as I see that it's an inequality, what do I know is going to happen to this construction? It's going to be split in half, right? So I got to know where I'm going to split it in half. How do I know where I'm going to split it in half? I graph the equality, yes? Oh, plus 5. So I graph it. And my slope, -2, 1, -2, 1. Everybody good? Now you're intelligent kids. This is set up with our variables on the left and our constant on the right, yes? Right? And it was set up the exact same way up here, wasn't it? Variables on the left, constant on the right. And the answer was everything that was on the left of the line, correct? So can we assume in math class, when it's set up the exact same way, that everything to the left of the line is my solution? Is that a safe assumption when it's set up the same way? In math, usually, yes. But it's easy to check. Where is 1, 3? 1, 1, 2, 3. It's right there. It's on the line, yes? So let's check. What is 4 plus 6? Is that greater than or equal to 10? 10 equals 10, yes? So that's okay. Does that tell us where to shade? No, because it's on the line. It doesn't tell me whether or not to shade up or down. So I need to check another test point. What is the easiest test point to use? 0, 0. Is 0 plus 0 greater than 10? No. So, can that be part of my solution? So did I shade correctly? No, because I saw it was constructed the same way except for that sign, yes? That sign said greater than, so I needed to shade over here. Is everybody cool? Now let me ask you this. When the test point we were given was on the line, we couldn't use it, could we? We had to choose a different one, yeah? Okay. And what one do I always tell you to choose? Okay, so now flip this situation around. What if it was this? Can I use 0, 0 now? So I got to choose what? A test point that isn't 0, 0. 1, 1. 0, 7. Make one of them 0. It doesn't matter. Everybody cool? Are we partying in the back now? What's going on back here? Okay. Is everybody cool? Easy peasy, yeah? Yeah? All right, now let me show you. No, we're going to wait on that. Yep, you get a break. We're stopping right there.